What's up, Algebra 1? So we're going to be talking about the last part of Module 2, Topic 2, that all has to do with solving. The first video was on solving equations. The second one was on inequalities. And now we're talking about manipulating formulas that have multiple variables in them and trying to get certain variables solved for. And so some students think this is a lot harder, but I honestly think that it could be easier because you're not really using a calculator, you're not really worried about putting values together as much as you are just moving them around based on those inverse operations. If you remember, the opposite of adding is subtracting. The opposite of subtracting is adding. Those are inverses or opposites, just like multiplication and division are opposite operations. And so you can use these to kind of manipulate your formula, move them around where you've solved for a different variable. So this number 67, and it may be a different number in your paper, but it's the same problem. This is the simple interest formula, a principal or amount of money that you loan. You can calculate the interest by doing the interest value times the rate times the time. So this is a very simple formula that's used a lot in business. And so all of these values are multiplying together. So I'm going to start by dividing the ones that I'm trying to move. I want to move I and R, trying to leave T alone. And when I do that, I and R come to the other side. So P divided by I divided by R, that has now been solved for the value of T. Now, that can be confusing. A lot of students like, whoa, I don't understand what that just meant. So I'll just do an example. Let's say you're doing 2 times 3 times 4. All right, because that could be like your I, your R, and your T. Well, 2 times 3 is 6, and 6 times 4 is 24. So I want you to imagine that I'm trying to get this third value by itself, this 4. And so I could divide the 2 times the 3 away. So I'm going to divide the 2 and the 3. Now, if you think about it, 2 times 3 is really 6. And if this value is really 24 divided by 6, well, that's the 4 that I'm leaving behind there. So really, we're just talking about, hey, if you have 3 numbers multiplying together to give you this other number, you can find that value by simply dividing the other 2 to the other side. And that's really the same thing as what we're talking about, except I, R, and T can be any number, not just those specific values. So I'm going to now work with another formula. This right here is the formula for perimeter of a rectangle. I know it says A, but really we're talking about P equals if we're talking about the perimeter formula. But anyway, let's try to get W by itself. And a lot of students think, oh, I need to distribute. You could distribute, or you could divide that value over immediately. There's several different ways you could approach some of these problems by doing the inverses correctly. So I'm trying to get W by itself. Let's subtract that L value over. And so A over 2 minus L equals W. Now you have solved for W. So I do feel like maybe showing you, like, if you had to distribute it, how that's not really any different. So let's say I had done that problem by not dividing by 2 first. I want to multiply by 2 first. Let's say you're going to distribute if you want to. So that would have been 2L plus 2W. Well, now I'm trying to get W by itself still. So I'll subtract the 2L over A minus 2L, equals 2W. And now I'm trying to get W by itself, so I want to divide everything by 2. And if you notice, these really are the same thing because A divided by 2, that's what I got right there. And if I was to divide negative 2 by 2, that would be this negative 1L there. So there's multiple ways that you can do the problem, and they would be the same as long as you do the inverses correctly. So let's do several of these. Trying to solve for x. So let's move the 6 to the other side. Y plus 6 equals 5x. And again, trying to get that x by itself. So let's divide the 5 over to this entire side. And that can be your answer. Y plus 6 all divided by 5 equals x. And now you've moved everything away from x. You've isolated x. And you've got x completely by itself. Very common. We call this standard form. In algebra, we have the standard form of a line. This is really helpful for doing word problems. It's also helpful for graphing using intercepts. So check out Module 2, Topic 1 if you want to see what that's all about. Let's solve for the given variable. They want us to get y by itself. So let's start by subtracting 2x over to the other side. Now some students want to do like 8 minus 2 here to get 6, but these aren't like terms. You really can't do 8 minus 2x. So I want to start by doing negative 3y equals negative 2x plus 8. Now some people may have put 8 minus 2x, not a big deal. But I like to write things in standard form, and that's not the same standard form as what I'm talking about here. Standard form means you put the largest variable exponent first, so that x is to the first power, and this one doesn't have an x, and so this is really going to start following like that mx plus b kind of feel for the equation. So that's why I did that. Next step is I want to divide by negative 3. And when I divide everything by negative 3, I get positive 2/3 x minus whatever 8/3 comes out to be. You don't need a calculator. You can just leave it right there in the fraction form. Let's try that with number 72. Again, trying to get y by itself. That, by the way, when they give you that value in parentheses, that's what you are trying to solve for. So, for example, they want you to solve for b in this one. If that's confusing, I wanted to clear that up. So for this one, I'm trying to get y by itself. So let's start by subtracting ax to the other side. So by equals negative ax plus c. And then to really get this y value by itself, let's divide everything by b. And again, that can be your answer. Everything is just very literal. In fact, we call this literal equations. We're moving everything around using inverse operations, but we're not necessarily like solving for them numerically. Let's talk about, let's see. Maybe we'll do 74. Trying to get L by itself, so everything's up against each other, so let's divide those to the other side. So to get L by itself, V divided by WH would leave L alone, and you would have it solved for. Let's try this one, trying to get X by itself. Let's add Y to the other side. 7X equals Y plus 14. And then I want to try to move that 7 to the other side, and now I have x by itself, y plus 14, all divided by 7. This one's kind of weird. I think they were really going for the circumference formula here, so I think we're supposed to have pi in that little space there. In fact, let's just assume that that's what it was. And let's solve for r. And so let's start by taking everything else, like 2 pi, and dividing them over to the other side. And now you have taken the circumference formula and solved for r. If yours does not look like that, when we could just divide by 2, and that would be c over 2 equals r. But I've done this enough that I know that they're really trying to talk about the circumference formula there. Just like this one here. This one is the area of a triangle formula. Area equals 1/2 base times height. So in geometry, if you were given a triangle and that base length was 8 and that height was 10, we could multiply them together and take half of it. 8 times 10 would be 80, and divide that by 2. This would have an area of 40. So that's kind of what we're working on number 77, trying to get b by itself. So let's start by looking around b and seeing what we can move. The first thing I notice is that it's dividing by 2. So I may start by multiplying 2 to the other side. So 2a equals 1b, and then the h. You can make that 1 invisible. It's understood in algebra if you don't put the 1 coefficient. And then if we're trying to get b by itself, let's divide h. So 2a over h equals b, and now you have solved for b. Hopefully that was helpful. If you have any questions, please see your teacher, and see you later.